All right, guys, today we're going to do the derivative of the inverse. And so pulling up those notes. All right, so we're going to talk about the derivative of the inverse functions, mostly trig functions, but there is a proof that allows you to find the derivative of inverse functions in general. And that's what this part in your kind of notes is saying here, that if you have a function inverse, first, what does it mean to be an inverse function? Inverse function is when you plug one function into another function, you get back x. So for instance, x cubed and the cube root of x. If I substitute this in here, I would get x, or if I plug x cubed into the cube root of x, I get back x. So it's like functions that undo one another, like natural log of x and e to the x. They are also functions that are reflections across the line y equals x, and their domain and range flip. So there's this property that the derivatives are opposite reciprocals, okay? Or I'm sorry, the reciprocals of one another. So like the derivative here is the reciprocal of the derivative at this point, okay? So, and I can prove that to you by showing you this part. This is just kind of extra information, but for those of you that like why is this the formula? If I take the derivative of this, I would get the derivative of f. Don't chew the chocolate, right? Keep this the same, but then multiply by the derivative of g, and the derivative of x is 1. And if I solve for this, the derivative of g, I would divide by f prime of g of x, which is this right here. That's what the formula is, okay? So using that formula, we are going to show how we could use that with a polynomial. It's find g prime of x if f of x is x cubed. So if f of x is x cubed, what is g prime of x? Well, g prime of x is 1 over f prime of g of x, right? So I have x cubed here. What's the derivative of x cubed? X cubed is 3x squared. That's the derivative, right? And we're going to do f prime. We're going to plug g into f prime. So g, what would g be here? If we know that f of x equals x cubed, g of x would be x to the 1/3. Okay, we're going to plug this into this. So it would be 1 over 3x to the 1/3 squared, or 1 over 3x to the 2/3. Most of the time I see problems asked not in terms of x though, but in terms of numbers. Like I would say, if I know that f of 2 is equal to 8, then g of 8 is equal to 2. The cube root of 8 is 2. And a lot of times they'll ask for like, what's g prime of 8? And what you do for that is you go 1 over f prime of g of 8, which is 2. The 2 is the x value for f. And so the answer here would be 1 over f prime f2. So you just find f prime, which is this, and you plug in 2. And so that would be 3 times 2 squared, which is 3 times 4, which is 12. So that would be 1/12. That tells you this question asked more often, but this is just a proof of what g prime is. But you could also find g prime by doing the power rule. It would be 1/3 x to the negative 2/3, which is what we got here. All right, that's more so just an introduction into what the derivative of the inverses are. It is very confusing, I realize, but let's the sine inverse, cosine inverse, tangent inverse, hopefully these are going to make a little bit more sense. So we're going to primarily focus on sine inverse, cosine inverse, tangent inverse, okay? So, sine, tangent, and secant. So derive the derivative formula for arcsine of x. First off, what is arcsine? Arcsine is another way of saying sine inverse. All right, and it's the undoing of sine. So if I would say that sine of pi over 6 What's the sine of pi over 6? It's right here. It's up a little bit, so it's 1/2. So that means that arcsine of 1/2 is pi over 6. It's just a way to read the function backwards. Now, if I want to find the derivative of the inverse, what I need to look at, as I know the inverse for arcsine would be sine. And if I want to illustrate what sine of x is, if sine of an angle, oh, sorry, let me write this differently. This is like y equals arcsine of x. If I take the sine of both of these sides, I get the sine of y equals, these undo each other, so equals x. And so sine of some angle equals x, so x over 1. And so SOHCAHTOA, sine is opposite over hypotenuse. So that means that the sine is x over 1. So I can find this length by doing the Pythagorean theorem, right? A squared plus x squared would equal 1 squared. So a squared would equal 1 minus x squared, and this side would be the square root of 1 minus x squared. So I'm going to write that here. And I know the derivative of sine is cosine, right? And the cosine value would be this over this, because it's adjacent over hypotenuse. So it would be the square root of 1 minus x squared over 1. And I know that the derivative of the inverse is the reciprocal of this. So it's the reciprocal of this guy. So the derivative of arcsine of x is the reciprocal 1 over the square root of 1 minus x squared. You do not need to know the proof. You just need to know how to use this. The derivative of arcsine is 1 over the square root of 1 minus x squared. All right. What I usually tell students to do is I tell them you're going to memorize this formula. And the other ones look very similar to it. And so I'm going to teach you kind of like a mnemonic device to help you remember. But I remember sine first. I remember the 1 comes first because there's the I in sine, and it kind of looks like a 1 because in secant the x squared comes first. So I want you to memorize this formula, that the derivative of arcsine is 1 over the square root of 1 minus x squared. Really, it's better written like this because of the chain rule. Because sometimes it's not just x here. You always have to multiply by the derivative of u. So I like this formula better, u prime over the square root of 1 minus u squared. So let's talk about tangent. I'm not actually going to prove it. I'm just going to write down the formula. The derivative of arctan of x is 1 over 1 plus x squared, or u prime over 1 plus u squared. Now sine was u prime over the square root of 1 minus u squared. I tell students to remember T for 2. There's 2 things that are different. What 2 things are different from this guy to this guy? What 2 things are different? There's no square root and there is a plus. And I remember the plus, you can hopefully remember the plus because we're with tangent and the T looks like a plus, right? So those are just mnemonic devices. How would I use this? Well, if I said, whoops, let me change my color. If I said, what's the derivative of arcsine, arctangent of 3x, you would say it's the derivative of 3x, 3, over 1 plus this quantity squared. And that would be your answer. These formulas look ugly and the proofs of them are a little bit scary and intimidating, but to apply them is not really that bad. Arcsecant, I'm going to write down the formula and I'm going to see if you can see what's different. Remember, sine is the one I told you to memorize. Sine is this. Now, secant, I remember, has a secant or a second u. And I remember then the u's are right by each other. Okay, so u, and there's the u squared minus 1 instead of the 1 minus u squared. So that's arcsecant's formula. So here's all the formulas written out. I know this looks very intimidating. Again, it's really, if you memorize this first formula right here, it's easy to get to the other one. So arcsine, memorize that the I and the 1 comes first, okay? Tangent, T for 2, you got plus and no square root. Secant is the second u. Then all of these guys, if you look at them for a minute, what do you notice? They all have a C and they all have a negative. So C is for change the sign. So you just change the sign. All right, so what's the derivative of arcsine of x squared? Well, it's just u prime, so it's the derivative of this over the square root of 1 minus this squared. All right, e to the something. Well, the derivative of e to the u is e to the u times the derivative of u. So it's going to be e to the arcsine of 6x times the derivative of this. So the derivative of arcsine is this guy's derivative over the square root of 1 minus that squared. We have to use the quotient rule here. So we're going to do the derivative of the top, which is going to be negative u prime over the square root of 1 minus u squared for arcsine. So the derivative of this would be negative 1 over the square root of 1 minus x squared times the bottom minus the derivative of the bottom times the top all over the bottom squared. This one we have to do the product rule because you have two functions of x. So derivative of the first times the second plus the derivative of the second, but its cotangent is going to be minus derivative of that over 1 plus that squared because the tangent is t for 2, and then times the first. Derivative of the first times the second plus derivative of the second times the first. Derivative of log, if you remember, it's the derivative of the stuff. It would be 8x over the stuff. You can simplify 4 goes into 8 2 times. So we would have this derivative here. And what happens? What do you notice? We have minus 2x over 1 plus 4x squared. And we have plus 2x over 1 plus 4x squared. So this actually just cancels. And you're left with our cotangent of 2x. Equation. When you were asked to write an equation, hopefully you know by this point you should think two things. Those two things are point and slope. So our point is root 2 over 4 comma pi over 4. Our slope is the derivative. So the derivative of secant is the derivative of u over the absolute value of u times the square root of u squared minus 1. So the absolute value of 4x, so we can kind of cross out the 4s. And we're going to evaluate it at this point. So plug in root 2 over 4. So what is that? I have 1 over square root of 2 over 4 times the square root of 2 squared is 2. And 4 squared is 16. And that 16 will cancel. That's 2 minus 1, which is 1. And the square root of 1 is 1. So we have 1 over square root of 2 over 4. So that's just flip that. So that's just 4 over the square root of 2. And you want to rationalize that by multiplying by root 2 over 2. We would get 4 square roots of 2 divided by 2, or 2 square roots of 2. So here's our point. Here's our slope. So y minus the y coordinate equals the slope times x minus the x coordinate. Implicit differentiation to find the equation of the tangent line. Okay, so implicit is what we did last lecture, where you have to multiply by y prime. Arctangent, okay, so arctangent is u prime over 1 plus u squared. So the derivative of this would be 1 plus y prime over 1 plus that squared equals 2y, y prime is what I did, it's not the way it is. And then I'm going to evaluate it at 1, 0. So 1 plus y prime over 1 plus 0 squared equals 2 times 0 times y prime. So that's all 0. So I get 1 plus y prime over 1 plus 1, so over 2 equals 0. So 1 plus y prime equals 0. So y prime equals negative 1. And it says find the equation. So I need my point and I need my slope. So y minus the y coordinate 0 equals the slope times x minus 1. So there we go. All right, guys, I know this unit can be tricky. Try your best, and again, reach out to me if you have questions.